Hello everyone, today I would like to introduce my topic, Fabric-based interactive system for creative music collaboration. Let me introduce my background a little bit. My proposed research area is music game for creative collaboration. The core idea is utilizing the attributes in music, including acoustic parameters and the social relationship involved in the music creation process, to develop a gaming system that can facilitate creative collaboration in the design team. While this requires systematically study in ISDN6810, I would like to explore the manufacturing techniques that are related to my research, and my area of interest is smart textile and computational music. E-textile and computational music is rather a new academic area of research, and it is a topic of interest across art and science, academia and industry, designers and technologists. In 1997, the first published research on e-textile was produced in MIT Media Lab. Then it came to fashion and design use, also military use. In the early 2000s, it became a playground for music performance and sound-generated objects. Nowadays, novel products like a MIDI jacket has appeared, and this technology has been utilized by larger corporations such as Philips, Levi's, Nike embed audio communication into clothing for applications like music players. So what is the benefit of combining fabric and music? Firstly, compared with hard and tough material-based musical instruments, fabric provides a softer sensation and can also be stretchable. Also, textile and fabric is ubiquitous in everyday life, so it is familiar to most people. If we integrate the music creation medium to textile, it may make this experience ubiquitous, and that can contribute to the area of ubiquitous music. Let's see some related work and the manufacturing techniques they applied. The first work is from EJ Tech Art and Technology Lab, who produced All Motion in Spiral. It is a site-specific sound installation that reshapes the gallery space by performative means of textile, spirals, sound, and light. The main techniques they use is printing conductive ink onto a piece of fabric and use magnet to trigger the movement of fabric, generating special sound in the meantime. The second example is from MIT Media Lab, the textile-based keyboard. Here they use different sensing mechanisms corresponding to different gestural expression towards the keyboard, triggering different sound effects. They produce the composite electronic fabric and the piezo-resistive fabric, connecting it to a computer for sound control. I am seeing there's an opportunity for combining advanced manufacturing techniques and the digital interface focusing on auditory stimuli. Taking the above work as inspiration, I propose a textile-based interactive creative system for collaborative music production. This system will contain several big-scale interactive fabrics, or so-called infrastructure fabric, and a projector or AR application that can produce visual corresponding to users' action. Here is an example rendering picture to demonstrate the components of the system. The main part will be several pieces of fabric in large scale. There will be different patterns on the fabric surface in a printed circuit way. For each fabric piece, there will be a small magnet device for triggering sound, and shown in the previous example. Each piece of fabric can be attached to a processor containing Arduino plus Wi-Fi module to send a message to the computer and invoking the computer to generate graphic based on interaction with the textile. Here is a demo. As you move the magnetic device, it will trigger the music played. I also want to include some fabric which is all in touchable manner. As we can see the red dot here, we can touch it with our hands and the music will trigger. That is the touchable fabric interface. Here is a storyboard describing the user. When the design team gets very tired after their creative discussion, they can stop for a while and play the fabric placed at the meeting room to collaborate some music for relaxing. And I also made an animation to show how the scenario will work. Here are the advanced manufacturing topics that I will cover. I will use laser cutting to produce special shapes of fabric, and will use the inkjet printing to print the circuit on the fabric in a more integrative way. And for the sound triggering device and other supporting parts, I plan to use 3D printing to provide some special structure and shape. I found a research article describing that the laser-induced graphene transferring conductive pattern to the textile can sense more flexible and sensitive movements. I'm not sure now, but I also want to have a try. And except for the manufactured part, I will use Arduino or LilyPad to process the data captured by the conducted fabric, and use a software called processing to generate visual effects that can be applied to the projector, and use Sony Pic to generate the sound based on the interactions. Here are some technical papers I found that can support my work. The first is from MIT Media Lab, where they developed a textile keyboard for generating music. They mentioned there are 4 mechanisms enable the textile-based sensing. That is called proximity and touch, electric field sensing, pressure, and stretch. For me, I will explore what kind of fabric will match this 4 sensing technique, and how will they match my music interaction mechanism and the visual feedback. Also, to test the capability of printing. Here is also a work from Imperial College. They use graphene-based TPU textile to make a composite sensor. According to the paper, this kind of sensor will sense the movement in a more flexible way. And this is an example called planar fashionable circuit board. Provides a perfect example for how a printed circuit can be transferred into a piece of fabric in a very small scale. And lastly, I want to introduce my tentative project plan. So basically, there are 3 challenges for my project. The first challenge is the research of material. So for this stage, I will spend 1 to 2 weeks to research on material properties and to purchase some sample, and to make a more complete plan about material testing and to define the interaction scheme. And the second challenge is to produce some small-scale prototype to proof of hardware connection with the Arduino and the music and visualization software. And my last challenge is the finished prototype. It will be a large scale and integrated different interaction scheme. So at this stage, I will produce the 3D printing sound triggering device, and also to produce the final piece of large scale fabric, and do a simple user testing. That's all. Thank you.